All right, so we have graphed cosecant and secant. Now we have to look at tangent and cotangent. Now, as we'll see in a moment, the tangent and cotangent graphs are very similar and very closely related. So don't worry too much about thinking of these as completely different graphs. But for now, we will go ahead and graph each of them separately. So we could, if we wanted, take a look at our unit circle once again while we're graphing these. And there's some really key points to look at. So you'll notice at pi over 4, this is a really easy point to graph because tangent of pi over 4 is just 1. We could also do these other points, so 0 and pi over 2. So let's say if we took tangent of 0, this is the point 1 comma 0. So this would be 0 here. And then tangent of pi over 2 is actually going to be 1 over 0. So this is going to be undefined, which will show up as an asymptote, just like we saw in the other examples. And then it's going to keep sort of going around. So at this point, we'll get -1. And we'll end up having a graph that looks something like this. So let's go ahead and label our axes here. I'm going to make sure to include a little notch for pi over 4 there, but I definitely want pi over 2, so I'll call that pi over 2. And then pi, we'll go to negative pi over 2. Let's go ahead and go to negative pi as well. Okay, so if you want to continue that unit circle, you could actually create a table if you'd like. I'm not going to do that though, but you could create a table of values and figure out all these points yourself. What you need to know though is that tangent has asymptotes again, just like the other functions did, cosecant and secant, and these asymptotes show up at all the pi over 2's. So if I had gone a little bit further on the x-axis here to 3 pi over 2, we would also have an asymptote there. The next thing you need to know is that the graph crosses the x-axis, so it has x-intercepts at all these pi values. And then the last helpful bit of information is we still have these points at 1 and -1, just like we did with sine and cosine. But the tangent graph doesn't kind of loop around. It actually, because it has these asymptotes, it sort of ends up doing this. Same thing over here. This pattern repeats itself. And so we sort of get these, it almost looks like a bunch of x cubed graphs that just repeat themselves. It isn't exactly x cubed because it's not x cubed, but it does kind of look like repeating x cubes, just like the secant and cosecant look kind of like repeating parabolas. So a couple of things to note about the tangent graph is that its period is not 2 pi like the other ones. This is the only graph, well, tangent and cotangent, this is the only one that has a period of pi. There's really no such thing as an amplitude because an amplitude is the max to a min value, and this doesn't have a max or a minimum because it goes to -infinity and infinity. So there's really no amplitude. We don't really think about phase shift on this one or midline and average value on these ones. So really the key word from what we've seen in previous examples is period. We don't really care about those other ones. We still will shift this horizontally potentially, but we don't really think of that as a phase shift. The next thing to note is its asymptotes. So the asymptotes for tangent are all pi multiples. So for example, we have -2 pi, -pi, 0 pi, etc. So those are the asymptotes. We also have, we could talk about the domain and range. So the domain is all real numbers except its asymptotes, except multiples of pi. And the range for tangent, and actually cotangent as well, is going to be all real numbers. Okay. Now this was a graph of tangent. Let's go ahead and graph cotangent now. Now with cotangent, everything sort of gets shifted over. So rather than the asymptotes being at all the pi's, if you were to create that table of values again, you would find that the asymptotes are at the pi over 2's. So we'll go ahead and use pi over 2 again. I am still going to mark these halfway points for the pi over 4's. This will be, we'll have negative pi over 2, negative pi, and then negative 3 pi over 2. Over on this side, we'll have 3 pi over 2. I guess since I have room, I'll go up to 2 pi. We'll see if I want to graph that far. All right, so let's go ahead and do our asymptotes first. The asymptotes in this case, shoot, I just realized I messed this up. This should say the asymptotes are all pi over 2. I was writing down all the zeros. All pi over 2. And just like I did before, that should actually be odd multiples. Sorry for the error there. I hope you were looking at this going, that doesn't look right, Mr. Edwards. I hope you fix your mistake. Oops. So let's go ahead and fix that real quick. So it's going to be things like negative 3 pi over 2, negative pi over 2, pi over 2, etc. And we can fix that by just saying odd here, odd multiples of pi. Sorry for that error. I was thinking of the x-intercepts, I think, instead of the asymptotes. Now that is going to switch for cotangent. So everything I was writing down does apply to cotangent. The asymptotes are now going to be at all the multiples of pi. So wherever you see something in terms of pi and not pi's over 2's, those are the asymptotes. Cotangent is still going to be 1 at pi over 4 because that ratio is still 1. And it's still going to be negative 1 at 3 pi over 4 over here. Except now the 0 is going to be at these points because if you look at the reciprocal, it's actually going to be 0 instead of an asymptote. So you'll notice the 0 of cotangent is the asymptote of tangent and vice versa. And so then the graph kind of looks the same, except it's been reflected. So you can actually think of cotangent as a reflection and a shift of the tangent graph. Excuse me. Okay, so once again, let's go ahead and talk. So the period is still pi. The only thing that's going to change is the asymptotes. So now this one is going to be multiples of pi, and then the domain is all real numbers except any multiple of pi. So what I wrote before that I had to erase is true down here. Again, sorry for that error. Excuse me. All right, so we have our setup. We know now a little bit of tangent and cotangent. I want to mention one more piece of information, which I already said, but I also want to write it down. So cotangent is a reflection and translation of tangent. And if we were to write this as an equation, we could say that cotangent of x equals negative tangent of x, right? So that negative makes it reflect, and then I'll just shift it over by pi over 2. So here's a relationship. You don't necessarily have to have this memorized, but this is kind of just a nice equation to write down. It kind of brings us back to when we did transformations back in chapter 1. So I just like to kind of use our prior knowledge to influence our thoughts here as well and kind of give us some idea of what's going on here. All right, so that concludes our tangent intro video. In the next video, we'll actually do some problems involving tangent.